right, so this section is going to be very similar to the last one, except this time we're looking at geometric sequences. These are ones where each element after the first is obtained by multiplying the previous element by a fixed number called the common ratio. So the formula that you would be using here, this is in your formula booklet. Now, if you need help finding your R value, and this is something that pertains to a question in your homework, you're going to divide two consecutive terms. So it says here u sub 2 over u sub 1, but it's just any two terms that are next to each other. So if it's easier to do it a little further on out in your sequence, you can totally do that. And then all the letters stand for the same things that they did back in the arithmetic. So u sub n is your nth term, u sub 1 is the first term, n is the number of terms, but then r now is that common ratio. Okay. So find the 10th term in the sequence here. We need to look to see what is it that we're multiplying by each time. So in this case, that would be 6 over 2 is 3. Now, if you can tell it just from looking, there's no reason that you have to divide, but like I said, you may not always be able to do that. So that's my r, and then my u sub 1 is going to be 2, and my u sub n in this case would be u sub 10. That's what they want me to find. So u sub 10 is equal to u sub 1, r to the n minus 1 power, 2 times 3 to the 10 minus 1 power is 3 to the 9th power. 2 times 19,683 is 39,366. Now, you may not need to show that much work there, however much you need to. Just be careful about the 10 minus 1. Don't forget to actually do that. And then if you are going to put that in the calculator, just go ahead and put it in as a 9. Otherwise, depending on what type of calculator you have, that 10 minus 1 might not work the way that you're wanting it to in the calculator. Okay. Now, the next one, in this case, again, we could divide to come up with our r. In that case, you could take negative 1/2 divided by 1 and come up with your r value as negative 1/2. Also, you can look at it with the fractions. I'm going back and forth from negative to positive and to positive to negative, which means that a negative is involved. And then the tops are multiplied by 1, the bottoms are multiplied by 2. So you can get the r value that way as well. My first term is 1, and in this case, I'm looking for the 11th term. So u sub 11 is the first term times r to the n minus 1 power. The first term is 1. The r value was negative 1/2 to the 11 minus 1 power. Now, in this case, it's not really necessary to write the 1, but I'm going to write it just because in other situations, if you have something other than a 1, you're going to need to write it. Okay. Now, you can put that in the calculator like that, but the thing is that they're going to want a decimal. They're not going to want a decimal. They're going to want a fraction. So if you put that into the calculator, it's going to give you 9.76 e to the negative 4. And even if you take that out of scientific notation, it's still not going to be a very accurate answer. So we can change that to a fraction. And I'll show you how to do that here in a minute, or you're going to take 1 times negative 1 to the 10th power and 2 to the 10th power. Well, that's going to be 1 times negative 1 to the 10th power is a positive 1. 2 to the 10th power is that. So the answer would just be that. Now let me show you how you would do that in the calculator. Okay, so let's say that we did type that in our calculator. So 1 times negative 1/2 to the 10th power. Okay, and then it gives me that decimal that I said it would give you. Okay, now if you hit the math button and then pick that very first option right there, it'll change that to a fraction. So same fraction we got there by doing it by hand. Okay. Next, we did a similar type of question here with this yesterday. So in this case, they told me that my 5th term is 3, and my 7th term is 0.75. Now actually, I'm going to do this in 2 different colors here. They want me to find the first term, the common ratio, and the 10th term. Okay, so in this case, I can write in a generic equation. To find the 5th term, I would take the first term times r to the 5 minus 1 power. To find the 7th term, I would take the first term times r to the 7 minus 1 power. All right, well, that's going to give me u to the 5th is equal to u to the 1st, r to the 4th power. And that would give me u to the 7th is equal to u to the 1st, r to the 6th power. Now, I need to find my r value to be able to find the first term and to be able to find the 10th term. So to find your r value, you divide. So I'm going to take u sub 7, and I'm going to divide it by u sub 5. Okay, so my u sub 7 was u sub 1 r to the 6th power, and my u sub 5 is u sub 1 r to the 4th power. Now, what happens is my u to the 1st powers, or my u sub 1's cancel out, and I'm left with, well, I'm left with what's there, okay? Now, let's do a little substitution here. U sub 7 was 0.75, and u sub 5 is 3. So that's going to be equal to r squared, because if I simplify that part of my fraction, 6 r's on top, 4's on the bottom, cancel out 4 r's, I'm left with an r squared. So now I can take the square root of that. Now, luckily for me, it comes out nicely. It's 0.25 is equal to r squared. So r is either positive 0.5 or negative 0.5. Now, look to see if both of those make sense. If I'm going from a 5th term of 3 to a 7th term of negative 0.75, would a negative make sense? Okay, well, I would take the 3 times a negative 0.5, which would give me negative 1.5. And then when I take that times a negative 0.5, it would give me a positive 0.75. So yeah, it actually could be either one. Now, anytime you're doing an even power, you're going to get a positive and a negative. If you're doing an odd power, you would end up with either positive or negative. So in this case, I'm going to have to do something special here at the end. Okay, so here's my r value, 2 possibilities. Now let's go back and find our first term. So use one of your equations that you've written there in that first step. I'm going to use the one that I wrote for the 5th term. So u sub 5 is equal to the first term, r to the 5 minus 1 power. The 5th term was 3. I don't know the first term, but let's say that r is 0.5. Now here's the deal. At this point, I don't have to do this computation twice, because if the r value was negative 0.5 and I take it to a 4th power, it's going to come out to be a positive. So I'll get the same first term in this case no matter what my r value is. So that's going to, if we solve that, we end up with u sub 1 is 48. Now, when I go to find the 10th term, though, I am going to have to worry about whether my r is positive or negative. So let's color code this, and we'll make this be the negative r value. Okay, and we'll do the positive r value in blue. So u sub 10 would be u sub 1 r to the 10 minus 1 power. So that turns out to be the 9th power. U sub 10 ends up being 0.09375. And that's exact. That's fine for you to give your answer like that. Now, what if, though, the r value was negative 0.5? Okay, in this case, since it's to the 10 minus 1 power, which is the 9th power, that makes a difference. A positive number to an odd is positive, but a negative number to an odd number is negative. So it ends up giving me the same answer, but it ends up being negative. So both of those are your answers. You have 2 possible r values, only 1 possible u sub 1, but then we have 2 possible u sub 10s. Okay, one more here. This one we want to find the number of terms in this geometric sequence. So I know what the last term is. I don't know what the r value is, but I can figure that out. And I do know what the first term is. So we're just going to do some plug and chug here. My R value, take two consecutive R's and divide them. They don't have to be the first two, but I end up with an R value of 3. My first term is 0.25, and the last term is that lovely number. Okay. So here's my equation. So 44286.75 is equal to 0.25. Don't know what R is. I'm sorry, I do know what R is. To the n minus 1 power. Okay, so we start to solve this here. Divide by the 0.25. I get 177147 is equal to 3 to the n minus 1 power. And we're going to solve this by graphing. Now, if you remember how to do logarithms, you could solve this using logarithms, but you're not expected to do that. So we're going to graph y sub 1 is 177147, and y sub 2 is 3 to the x minus 1, and we'll look to see where they cross. Now, you can kind of guess and check just to get an idea of what that x value is going to be. The one thing that's tricky about this is that it's a huge graph. I need my y to be almost 200,000. So I'm going to go to my graph here, okay, and I'm going to go to my y equals, and I'm going to type in that stuff we just talked about. Okay, so that's going to be 177147, and then 3 to the x minus 1. Now, mine went ahead and put it up in a power here, but if it doesn't, make sure you put it in a parenthesis. If I graph this right now, I'm not going to see anything because my graph only goes to 16 for the x's, and then it goes to 10 for the y. Now, I don't know how big my x's need to be, but let's just go from negative 20 to 20 just to see. Okay, and we'll go by 2's. For my y's, I need my y to be almost 200,000. So let's go from 0 to 200,000. It's good to go a little bit higher than what you need to go to give yourself some space. Now, I don't want to go by ones because that would be 200,000 ticks. If I did 100,000, that would only be 2 ticks. 10,000, let's do 10,000. And let's see what that looks like. Okay, so there's my 177,147. Okay, and then here comes my red graph, and then it touches it. Okay, now if your graph was not the right size, then you need to make it bigger. Can I see the top? Maybe I don't see the red come all the way up there, then I need to make my x's larger. So now we're going to go to calculate, which is second in the trace button, and we want to go to intersect. So go to where the graphs intersect. And then hit enter 3 times. So it turns out it's exactly 12. So that's my answer. Now, in this case, since it did come out to be an exact number, that's something that you might have been able to guess and check. But if not, you can use the graphing method there. Okay, next. We have a car whose original value was $34,000, loses 15% of its value each year. Write a geometric sequence that gives the year-by-year value of the car. Okay, so they're wanting an equation for the sequence. In this case, we are losing 15%. Every year, we're going to lose the same percent. So this is going to be geometric because in order to lose a percent, that's going to be an R value of 1 minus 0.15. Or 0.85. I'm going to multiply by 85% every year. That makes it geometric. Okay. So in this case, my first term would be the 34,000, and I've got my R value. So U sub n is 34,000, 0.85 to the 6 minus, I'm sorry, that's the next step, to the n minus 1 power. Okay, now find the value of the car after 6 years. 34,000, 0.85 to the 6 minus 1 power. Of course, that's to the 5th power. That gives me this amount of money. Always run money to 2 decimal places unless they tell you otherwise. Now, after how many years will the car value fall below 10,000? Okay, my ending amount is going to be 10,000. I'm starting off with that same amount here, and here's my the rest of my formula. So this is going to be like the last question that we did on the front there. We're going to divide by 34,000. Now that turns out to be not such a nice number. Okay, so we're going to just leave it like that for a minute. It turns out that that fraction will reduce to 5/17, and I'll show you that math here in a minute. And we're going to use the calculator to solve this again. So I'm going to have my y sub 1 be 5/17 and my y sub 2 be 0.85 to the n minus 1. Now let me show you the 5/17 part. When I take that fraction there, the 10 divided by 34. Okay, so there's my not so nice decimal. But if I go to math and I go to fraction, it will give me the simplified version of that, which is the 5/17. Okay. So I come here to my y equals. I graph the 5/17, and I graph the 0.85 to the x minus 1. Okay. Now this time I'm going to have to change my window again. So this time I don't need my y's to go up to 200,000. So let's, I don't know what the x value is going to be, but I'm just going to leave it the same. And we can change it if we need to. Let's make 5/17 is less than 1. I'm just going to make it go to 2. And then let's go by 0.5. No, let's go by 0.1. That'd give me 20 for my scale, and 20 is a pretty good scale. So there's my 5/17, and there's my other graph. So plenty big enough. Okay, and then now we're going to calculate again. Calculate, intersect. So we're looking for the x value. So about 8.5. We do 3 sig figs, I guess. Actually, we should. That would be 8.53 years. Okay. So after 8 years, it hasn't fallen below 10,000, but after 9 years, it will have. Okay. All right. Okay. Another one. Okay, now we have people increasing by 2% each year. The population at the start was 12,500. What is the predicted population at the start of 2010? Now, sorry that there was that gap there. We're starting at 1970. We kind of have to know that to be able to go on here. This one, we are increasing by the same amount each year. So in this case, my R value is going to be 1 plus that percent, which is 1.02. My first year would be 12,500. Now, here's where we have to be a little careful here. Now, the year 1970, that's U sub 1. I need 2010. So think about, okay, if 1969 would be year 0. If I were to subtract those two terms, I would end up with 1 year. So U sub 1 minus U sub 0 is 1 year. I'm plugging in 1 into my equation to get 12,500. So I need to know what 2010 is going to be. So I'm going to take 2010 minus 1969, and that gives me 41. So 2010 would be U sub 41. Now, what you can do on a smaller scale is just kind of try something simpler. So like, okay, what if I went to 1980? So 1970 would be year 1, 71 would be year 2, and then continue on from there, and then you can see, oh, well, you can kind of take that and work with it, okay? If you don't like my method, come up with some method that you can, because you don't want to have to count 41 years, okay? But that's what 2010 ends up being. So now, my use of n is 12,500, 1.02 to the 41 minus 1 power, 12,500, 1.02 to the 40th power, and we end up with that to 3 sig figs. Okay. All right, so that's all my sequence questions. Now, what about if we go to a series? Okay, a series now is going to be a sum, just same way we did yesterday, but different formulas. Now, the formula booklet gives you 2 formulas. They give you this formula, and they give you this formula. Now, right here, it has, hey, use this one when the absolute value of r is less than 1, and hey, use this one when the absolute value of r is greater than 1. It really makes absolutely no difference. You'll get the exact same answer either way. It's really just a process of trying to not end up with a negative on the bottom, but it doesn't matter. You're using a calculator anyway, so use whichever one you want, okay? But only the part circled in blue is what's in your formula booklet. Okay, so first one here, find the sum of the first 9 terms. Now, one thing to notice about this formula is I do not need the last term. I just need my first term, I need my r, and I need how many numbers am I adding up. And I have all that in this one. My r value is 2. I'm adding up 9 numbers, and my first term is 2. Now, I'm going to write this in a different color because I hate the fact that the r and the use of 1 are the same thing. Now, if we use the reasoning up there at the top, we would use that second formula, just because if I use the first formula, I have 1 minus 2 and I get a negative on the bottom. So I'm going to go ahead and use this formula just because this is the one that won't give me a negative on the bottom, but honestly, it really doesn't matter. So in this case, I'm going to have my first term is 2, 2 to the 9th power minus 1 over 2 minus 1. That's going to give me 2 times 511 over 1, which gives me 1,022. Okay. Now again, if you did it with the other formula, you'll end up with a negative on the top and a negative on the bottom, and the negatives cancel out, and you still get 1,022. Now remember, you can use the calculator to help you out with this, definitely typing it in. But in this case, I don't have a formula, so I can't use this sum sequence to do the formula or to come up with the sum. That's another reason why you need to make sure you know how to do this by hand. Okay, next, same thing, but this one my r value is going to be a little bit harder to figure out. In this case, my r value, I'm going to take 18 divided by 24. Those are 2 consecutive terms, and that ends up giving me 0.75. Now, if you did it in the other order, you would end up with a number bigger than 1, which won't make sense. If I take 24 times a number bigger than 1, I'm not going to get 18. So if you can't remember which order to divide your numbers in to find your r, do it one way and see if that order makes sense. Okay. Now, my n in this case is going to be 12, and my first term is 24. Now, in this case, since my r value is a number less than 1, let's use the other sum formula this time. The one that will not give me a negative on the bottom. And let me just double check that I wrote that down right. Yeah. Okay, so my first term is 24, 1 minus 0.75 to the 12th power over 1 minus 0.75. Be careful on this one. Don't write n minus 1. I know that's hard to do because you've been writing it for all these other problems, but we don't want to do that. Now in this case, I really don't need you to show me any work other than just that. If you plug in that 1 minus 0.75 to the 12th power, you get a really long decimal. And I really don't want you to round that off, okay? So just do it in your calculator, so in one step. So do 24 times that top part divided by, now if you're going to do it in one step, put that bottom in a parenthesis. Okay, otherwise, go ahead and just do the computation of the 1 minus 0.75 beforehand. This gives you 92.959. Now, this is not one that you can change to a decimal or change to a fraction. So just 93.0, and that's 3 significant figures. If I want you to give me an exact answer on your quiz or on your test, I will tell you that. Otherwise, feel free to round to your 3 sig figs. Okay. All right, a couple more here. This one, we know the second term and we know the sum of the first 2 terms is negative 15. We're going to find the first term in the common ratio. So this one's kind of a neat problem. My second term is negative 30. The sum of the first 2 terms is negative 15. Find the first term and the common ratio. Okay, well this one's way easier than maybe you were thinking when you read it. So I'm going to plug in my second term. I'm adding them up. I'm just going to solve. My first term is 15. Okay, now find your common ratio. My R value would be the second term divided by the first term, which is negative 2. And that's it. Okay, now we have a story problem, and then we'll have one more with a sigma, and then we'll be done. So we have a company is offering Abid a job with an initial annual salary of and a 4% raise each year. This raise continues every year. Okay, so in this case we have this 4% raise. That means that my R is going to be 1 plus 0.04 or 1.04. Now the reason it's 1 plus, because I don't know that I said that earlier, or 1 minus, is because it needs to be what you're multiplying by. If I use just 0.04, then the next year I'm only making 4%. I want to make 4% on top of what I made the year before, which is why 1 plus 0.04. Okay, so what's going to be the salary after 5 years? My initial salary is this, and N would be 5. Excuse me. Okay, so obviously that would be 4. We end up with $32,756.04. Now, how much will he have earned after 15 years? This is going to be a sum, okay? It's not in how much will he earn in 15 years? I think that means more of in the 15th year, how much is he getting? Like, how much is he making? What's going to be on his taxes? In this case, it wants to know, like, how much will he have saved, okay? So my first term in this case is $2,800. My N is 15. My R is 1.04. And this is a sum, okay? So since my R value is bigger than 1, let's use this formula. Because I don't want to get a negative on the bottom. So 28,000, 1.04 to the 15th power minus 1 over 1.04 minus 1. And we end up with $560,660.45. Now this would be one you wouldn't, I mean you could find all 15 years and add them up, but man, that would take a lot of time. All right, last one. We've done this problem before with a sigma. Just wanted to make sure you knew how it related to a geometric sequence. So in this case, we've got 2 options again. Method 1 would be to write out all 5 terms. So my first term would be where I is equal to 1. 5 times 2 to the 1 minus 1 power is 5 times 2 to the 0 power, which is 5 times 1, which is 5. U sub 2 would be 5, 2 to the 2 minus 1 power, which is 5 times 2 to the first, which is 10. And after doing just a couple here, you'll realize what the pattern is, and you can totally just repeat the pattern. Okay, we're multiplying by 2. So U sub 4 is going to be 40, and U sub 5 is going to be 80. So your sum now, you're going to add up those 5 numbers, is 155. Now, that's not a bad method. I've only got 5 numbers. You know, that's fine. But what if I've got 15 numbers? What if I've got 50 numbers? Then I want to use one of the formulas. So here's my formula to find the sum of a geometric sequence. Now, how do I know it's a geometric sequence? Either they tell you or you notice, hey, I'm multiplying by 2 each time. If I were adding 5, just looking at those first two terms, it could have been adding 5, but it's not. So once you figure out what the pattern is, if the pattern is arithmetic, use an arithmetic formula. If it's geometric, use a geometric formula. Okay, well, I know my first term is 5. I already did that in the first method, but if not, plug in 1 to find the first term. I need my R value. Okay, I don't know my R value, but if I find my second term, I can find the R value by dividing. Okay, so there's my R, there's my first term, and I need to know how many numbers. Well, I'm going from, on my sigma, I'm going from 1 to 5. That's 5 numbers. Let's put this in red since we've got a duplicated number there. Okay, so my first term is 5. 2 to the 5th power minus 1 over 2 minus 1. I'm using that formula because my R value is bigger than 1, and this way I'm not going to get a negative, but again, it doesn't matter which formula that you use. 5 times 31 over 1 ends up giving me 155. So, same value there. Okay, so you've got kind of a hodgepodge of questions, a little bit of each one here, and that's it for what's going to be on your quiz. So I know that is quite a bit of stuff, and we'll add some more stuff to it before we take a test. Tomorrow you'll have a worksheet over just this stuff, and that's the kind of stuff that you would see on your quiz.